Day 10,
Hello,
Car
and
Audio
welcome
School.
to Day 10. This is your car audio school where we teach you how to install it yourself, become a technician to get a job at a shop, or become a shop manager or owner. I just added that in. This is for entertainment and educational purposes only, and this is my online resume, my body of work that will teach you how to stay out those shops and do it yourself. So today we are talking about battery and charging systems. So I got a lot going on here, but we're going to try to get through it in like 12 minutes. So we have to go back to Watt's law, really Ohm's law, because it has a lot to do with it, but we'll start at Watt's law. And what we want to remember is Watt's law is super simple: power in watts, voltage in volts, and current in amps. It tells how the electrical power is related to the push of voltage and the flow of current. So with that being said, we're going to come over here to these notes. And we're going to talk about understanding the flow. So electricity and electrons at the most basic level. Electricity is the movement of electrons, water, from one atom to another. And I keep saying water because we can visually see how that moves. We'll call it in a circuit, but we're saying the same thing. Think of it like a continuous stream of tiny particles, water, flowing through your car's electrical pathways. We'll call that a drainage system or water system. We'll call it a water system, which we call circuits. Understanding this fundamental movement is the first step to grasping how your car's electrical system works. These electrons move in a path from beginning to end, so it does have to have its path of return where it starts at. It pumps it all the way through, and then there's a path of return. These electrons move in a path from beginning to end, and understanding when, how much, and why they move is the key to understanding electrical circuits. So the power behind it all: watts, voltage, and current. We measure in electrical power in watts, and then power is simply the conversion of one form of energy into another over a period of time. So just like we were talking about the pinwheel, so there is voltage, it's like the height of the water. So the push of the water. So when we were talking about the pinwheel and the water cascading and falling over onto the pinwheel to turn it, that's what we would call the work or the power of the windmill. We'll just go there. Electrical power is determined by the voltage, electrical pressure, so the water cascading, the push of that water falling onto the pinwheel to turn it, and the current, the flow of electrons, so how much water is coming through within a circuit. It is important to remember this essentially when considering power-hungry accessories like high-end amplifiers. And then the battery's crucial role. So your car battery has two main functions. Function number one, and we talked about this yesterday or the day before, but we're going to get into it right now. The primary job of the battery is to deliver high bursts of current at a stable voltage to crank the engine and get your car started. So remember, we said that the only and primary use of the battery is to start the engine. Once that engine is started, the alternator takes over and starts pumping electricity through the system. All of this goes through a path of return, we'll call it the chassis, which is ground, which is attached to the negative post of the battery. So that's how that works. Batteries with a high cold cranking amperage CCA rating are designed to do this efficiently, sustaining engine cranking for longer periods of time. However, it's worth noting the battery with a higher CCA will also require more electrical energy from the alternator to maintain its charge once the engine is running. So this goes back to, I'm not sure if we talked about it, but so your alternator is specific for that vehicle out of the factory. So, and just to keep the math simple, let's say you have a alternator that provides 300 watts of power to continuously charge it. We'll just say that. That alternator, most of the time, cannot keep up with the pump from the battery. So your battery is a storage and the alternator is a charger. Adding more equipment, 1,000-watt amps, in some cases 5,000-watt amps with 1 to 300 watt speakers. All of this is sucking more energy out of the battery, out of the alternator than the alternator and or the battery can provide. So think of it like pouring water into a cup with a hole in it. The bigger the hole or the bigger the draw on the system, the faster you need to put water back into that container, that battery, or the alternator needs to output to keep the vehicle running, because there will be at some point that your cup or battery will run empty and your alternator cannot keep up the demand on the electrical draw to those systems. This is why when you're at a light or at a complete stop and your base hits, the lights dim or the RPMs drop. You're sucking more power out of the vehicle that the vehicle actually needs. So this is why we upgrade our batteries, and this is why we upgrade our alternators to output more energy. And in most cases, you'll add another battery just to have another bank of water or another cup of water that has a hole in it. Now you have 2 cups or batteries drawing slowly, then 1 cup of water or a battery draining very quickly because there's a big hole in it, figuratively letting all of the energy go into the car being consumed by these I'll say appliances, but amps and everything else that you would add into a vehicle. How we doing on time? All right. I'm trying to find where I left off at. However, it's worth noting that a battery with a higher CCA will also require more electrical energy from the alternator to maintain its charge once the engine is running. Supersizing a battery getting a bigger battery, does not always guarantee extra power for accessories and might just increase the load on the system. So just because it's a bigger battery doesn't mean there's a bigger hole or outlet for energy or water to drain out of into the system to keep it fed. Filtering AC ripple. This is good. So the battery also acts as a crucial filter for any leftover alternating current ripple or leakage from the alternator's direct current output. So the alternator can, like I was saying with Chevy Suburbans and I want to say bigger Cadillacs, those alternators are only meant for that system. But once you start putting a strain on it or more, it needs to output more power, it winds. The rectifiers that turn the AC power into DC power aren't efficient for the new job or task that you're putting on that alternator or in that vehicle. The alternator converts mechanical energy into electrical energy, and this process involves converting AC to DC using components called diodes within a rectifier. A healthy battery and the vehicle's largest capacitor or voltage storage device smooths out the alternating voltage levels, ensuring a stable DC supply for all your car's electronics, including sensitive video and audio systems. So if you ever see wavy lines in video, that is the same thing as audibly hearing static through your speakers. Even a weak battery can fail to adequately filter this ripple, potentially causing noise in your audio system. If the diodes in the alternator's rectifier are failing, they can also leak AC, leading to significant audio system noises. Cool. So ancient on versus off. Power source dynamics. When your engine isn't running, the battery is the sole source of power for all the vehicle's electrical systems. However, once you start the engine, the alternator takes over as the primary source of electrical energy. At this point, the battery is essentially becomes another electrical load that consumes energy from the alternator to maintain its charge, while still performing its vital filtering functions. I have another section about hybrid and electrical vehicles, but I'm going to make that its own section because that's its own different beast. Performs the same, but is the car on? That part. I'll give you one more. The alternator, your on-demand power generator. The alternator is the backbone of your electrical system when the engine is running. The internal combustion engine vehicles, its primary source of electrical energy and also recharges the battery. So it's talking about the alternator when the engine is on, recharging the battery, along with supplying electrical for the whole vehicle. Inside the alternator, as mentioned earlier, the rectifier with diodes converts the AC electrical generated into the pulse DC needed by your battery and the rest of the vehicle's electrical systems. Understanding this AC to DC conversion process is key to diagnosing issues like AC ripple and its impact on the audio system. So with all of that being said, I have developed something I call the one sheet, where it will take your alternator, your battery, and weigh it against the amp that you want to put in there, the radio that you want to put in there, the speakers that you want to put in there, the lights, underglow or interior ambient glow, anything else you can think of to put inside of a car, and it will tell you, well, what do you need to upgrade? Do you need to do what's called a big three? Do you need a new battery? Do you need to upgrade the alternator? How are you going to sustain this level of performance with what you already have in there, as compared to not doing anything at all and putting a serious tax or drain on the system that you already have in your vehicle, system being your battery and your alternator that you have in there already. And it'll help you pick out the best system. We're at 15 minutes. I'll leave you with this. A lot of technicians or salespeople will will just sell you anything, and on the back end, you'll deal with the consequences of having a power-hungry system, and it keeps shutting off, and you don't know why. But I'm telling you why it does that. So we'll be back tomorrow. Donate. Help us get Mixture One, All Data, and Direct Tech. Always tip your technicians. My donation info will be in the caption or whatnot. And we will be back tomorrow with some more info. I'm setting up YouTube, so we're going to be doing very long form, even though this is kind of long form, but I will see you tomorrow.